Hello everyone! I know it's been several months since my last update video, so I figured it was about time to fill you all in on what I've been working on. I have about 3 projects currently swirling around at various stages of development, and I'm going to go through them one by one and share what the latest status is. So the biggest project of all is the Printalizer Enlarging Timer and Exposure Meter. This is the project that originally got me started in the world of darkroom electronics, but also is the one that's sort of been taking the longest to come to fruition for a number of reasons. The original prototype, which I've shown off before, was made quite a long time ago now. And one of the main things I've been working on in this time has actually been the second prototype, which looks like this. It's very similar, but the construction is a bit different. It's made out of thin galvanized steel instead of aluminum, and a different company manufactures the enclosure. It's also a little bit bigger and has this additional XLR jack on the back, which is sort of this expansion port that I see as part of this grandiose idea of being able to also control highly sophisticated LED enlargers in addition to traditional darkroom enlargers that are just controlled by relay switching a couple of outlets. Now, I've been spending most of my time since the last video working on this prototype, both constructing it and updating the firmware to deal with its new features. And right now, I'm actually only maybe a week away from building the third prototype. The third prototype is going to be very similar to this, just a little bit narrower because I found some ways I could take a little bit out of the width. And the foot switch connector jack right here is just going to be moved a little bit for assembly reasons. But it should otherwise look very similar to this. So this is sort of my main long-term project, which I would love to bring to market sometime within the next year or two. The biggest challenges are that the firmware is somewhat complicated. It does have some features that I could work on forever before ironing out all the kinks and getting it to everyone's satisfaction. And the construction is a little bit more complicated just because not everything inside can be machine assembled. However, it is the project that I do ultimately want to be able to provide someday. Oh yeah, and there's one other issue. It's probably going to be fairly expensive, or at least more expensive than I originally wanted it to be. And that's just because it's just the bill of materials. It's not actually any more of a profit margin than anything. It's just the enclosure costs a lot, and a lot of the components on the circuit boards, it just kind of adds up after a while. But hopefully I will be able to offer it eventually, and it'll be this versatile product that can keep improving with firmware updates for years to come. So one thing I did want to sneak into this video is a quick little demo of how the LED enlarger control features work using the DMX512 compatible port at the back of this enlarging timer. So let me zoom in on the screen just to show you some of the settings. So one thing that I've added is safe lights can now be controlled either through DMX or through a traditional relay switched outlet, and you can do one, the other, or both. And just for the safe lights, you can set up the address, whether you want to use 8 or 16-bit control, and then what brightness level to use. Now for enlarger configuration, there's now an enlarger configuration profile where you can name an enlarger, you can control it via either DMX or a traditional relay control. And then for your channel sets, you can either do white only, RGB, or RGB and white, depending on what you have. And again, also 8 or 16-bit control, and then you can specify the different channels. For contrast, you can either do traditional white with filters or a configurable green-blue combination. And then we have other settings like how bright do you want to be when focusing. Do you want to have a safe mode where at certain stages like in between dodge burn steps or in between test strip steps, the light will switch off and switch into red if you can do that. And also you can have a profile of what brightness settings for what contrast grades. The details of this I'm going to be tweaking over time. This is just really a first pass. I know there's room for improvement. I've been doing a lot of research with some of the existing RGB LED enlarger products on the market, and I've been seeing how they work, so that's certainly given me ideas. Also, another thing that this adds is now it's either black and white printing or color printing. And in color printing mode, you can control the individual channels. Again, this is only if you're using a DMX control of an RGB capable enlarger. And there are also a few different ways I can improve the way this works, which is something that I will be revisiting in the future. But now let's go back to just normal black and white printing, and we'll do a little demo. So I hope it doesn't overwhelm the camera too much, but I have two DMX light fixtures set up. These are RGBW capable fixtures. These are just simple stage lighting doohickeys, but they're cheap and they're very convenient just for doing testing for a project like this. So this one is currently configured to be the safe light, so as you see it's emitting red. And this one over here is configured to be the enlarger. So if we go into focus mode, as you see, the enlarger one turns on a bright white light. Now, if we shut off focus and we actually go to do an exposure, you will see that the safe light will shut off and the exposure will turn on in a green-blue combo. And let me just shortcut out of that. Now, if we were going to do a test strip, let's reduce the time a little bit, and I'll show you that sort of safe lighting mode. So with a test strip, we're in test strip mode now. As you see, the lights have turned on in red, and as I expose, it will flip back and forth. And of course, that will be configurable in case you don't actually want that behavior. So that's just a little neat demo of some of the things that can be done. Now, if you do want to control any of the existing LED-based enlarger products on the market, I have been experimenting with how that would work. You would probably have to build some kind of an adapter, but I should be able to publish some reference designs for those adapters. Whether I sell them directly or not, I'm not really sure yet. But those products aren't really designed to be externally controlled, though it absolutely is possible, and I already know how to do it, so it's just a matter of documenting how. If you want to build your own LED-based enlarger, things actually get much easier. You can go and directly buy an LED driver that's controlled via DMX and just wire up the jacks and you're good to go. You don't really need to design any circuitry at all. You can build it entirely out of off-the-shelf components. And you can even get one that can do 16-bit control, which is actually quite important if I want to provide more sophisticated features for controlling brightness on a logarithmic scale, for better contrast control, or for color printing. So that's a quick demo of what I can do with the DMX port. And that being said, back to the rest of the update. The next thing that I've been working on, but it's a little more backburnered at the moment, is the color densitometer project. That project has run into some hurdles, namely because there are a couple of ways I can build it, and they all really have problems. So the first way I was thinking was using something called a multispectral sensor, which is a sensor that is sensitive to a wide variety of different wavelengths that it can individually measure, but I don't really have control over what these wavelengths are or how accurate they are out of the box. So in order to measure with wavelengths that actually match the standards for color densitometry, I would need to be able to do a lot of calibration and a lot of math, and there's still no guarantee that the results will actually match other color densitometers across every possible material. So while it's a great idea in theory and could produce a device that doesn't actually cost more to manufacture than my current black and white densitometer, the amount of calibration effort would be insane, and the likelihood that it would give readings that wouldn't make everybody happy would be rather high. The next option is to use a sensor that has a broader amount of spectral sensitivity. And there's a few options here. It could be anything from a particular AMS sensor that has 18 channels instead of 11 to 14 from the one that I previously mentioned, all the way up to a full-blown mini spectrometer. Now, these sensors all have a problem of sensitivity to low light. They all basically hit their noise floor the moment you try to measure any sufficiently dense material. The AMS one has the problem that it's sort of this 3-sensor chipset where just lining everything up, I'd lose light as it is. And the fancier mini spectrometers have the problem also of being very expensive. But they all have limited low light sensitivity. So while any of these could probably do the job, and even allow me to make a full-blown spectrodensitometer, which could be a really cool instrument, I don't think anybody would like it too much if they couldn't measure anything with a density over, I don't know, 1.5 to 2 at the most. I think people expect the densitometer to handle anything all the way up to 4. So that's a bit of a challenge. I've been doing some experimentation with the mini densitometer sensors, and there's another, with the mini spectrometer sensors. And there's another one that I want to try out that I haven't tried yet that might do better at low light, but I won't know how well it works until I try. Regardless, going that route would result in a rather expensive device, and I'm not sure how big of a market there would be for something that costs 2 to 3 times as much as my current product, while not really seeming that much more substantial, aside from its capabilities, of course. The third project, however, is one that I think has a lot of promise and may not be that much work to bring to fruition, and that is a UV-capable densitometer. That particular project I've decided for now to put under the working term of UV/Vis densitometer for UV and visual. The idea is it will be a single unit that can measure both UV transmission density and normal visual range black and white transmission and reflection density. This product, which I'm not going to officially announce until I've gotten past at least the first round of prototypes and have proven it all out, could wind up being a future replacement for my current densitometer, or it could be just a second product that I sell alongside. It probably will cost a little more, but not that much more. The key to this is a different sensor that has sensitivity in both the visual range and the UV range, and of course, obviously adding a UV light source. The big open question with this product is due to a lack of any official ISO standard on UV densitometry, not knowing what wavelength to use for the UV light source, but that's something that I can figure out later. It really just speaks to how I decide to master my calibration references, and I have some options there. So that's basically what I've been up to. And if you have any questions, feel free to ask below or hop on our Discord, and I'll see you later. Bye!